Alright, welcome to a new video. So you've seen the title of the video, you know what we're doing. We are going to be setting up Grbl, Grbl, I don't know how to pronounce it. I think it's Grbl, kind of like gerbil. So anyway, we're going to be setting that up on this Arduino Nano microcontroller. So I have a few bits, got a little stepper motor here, DRV 8825 stepper driver. So a lot of the time when people set this up, you can buy a board that has drivers populated on it and some convenience pins, and it has all the pins wired up for all the correct I/O. You can buy a kit which has an Arduino Uno and in the form factor of a shield, the board that pops on top. I'm not doing any of that because this is just one part of a wider project that I'm doing. The project that I'm doing is where I'm basically going to be creating my own driver software for that interfaces with Grbl. So Grbl runs, for anyone who doesn't know, it is a very lightweight but highly powerful hobby level CNC control software. Runs on an Arduino. It accepts serial commands over the USB, and then it'll do stuff. So basically you connect it to a computer, you run a piece of software that will send G-code commands one at a time to the controller executes that with its motion system, driving your motors and your spindle and all your other bits and pieces, and stops, probes, all that good stuff. So that part is the part that I'm making. That is the software that sends the G-code. So there's off-the-shelf softwares you can get. Some of them you have to purchase. Some of them are free. Some of the free ones happen to have limits to how big a file you can upload, to how many G-code commands, etc. I want to build my own one. There's some specific tools that I want to build that'll all come later. This is just the first step of it, is that I need a little test setup. So minimal test setup. It's going to have the Arduino. It's going to have a single motor with a driver. I'm going to wire it up, run Grbl on this, and then just be able to interface with it so that I can test it out and make sure it works. So yeah, that's kind of step one of this project, is to do this. This is all also kind of feeding in that at some point in the future, I want to write my own full CNC control software, which is I want to write my own version of something like Grbl. And then also the high level control software as well for it. Just something that has taken, that I can't get out of my head, to be quite frank. You guys may have noticed on this channel, I basically just lurch between whatever projects are taking my interest at the moment. And at the moment, this is one that is top of my mind. I can't really get it out of my head, so I'm going to work on it. I've wanted to do this for a long time. It keeps coming back up, which is why I've decided, damn it, I'm just going to do it. So that's what we're doing. That's this whole thing. Is the very start of this journey of what I'm doing. So yeah, gotta install. Very first thing to do is I'm going to install Grbl on this Arduino Nano. I've never actually done that. I've only ever installed it on an Uno. I assume it'll just work the exact same on the Nano. I think it should. I don't think it should be any difference. So yeah, I'm going to do that. And what I'll do, because I've talked about Grbl on the channel before in my DIY CNC build from years ago. But yeah, I'm going to go through a little bit about how the setup works on this. It's very simple, very straightforward. But yeah, I'll talk about the installation and how you set it up. I'll wire this up and yeah, get to at least that stage by the end of this video. I'll be able to show you guys just a very minimal working example of Grbl running. So that's next. Let's get into it.
So the process of setting up Grbl itself is pretty straightforward. Now, I do say that as coming from a software engineering background, so maybe some of the tools for some less software inclined people might be a little bit new, but it's all pretty okay. So basically you want to head to their GitHub. I'll throw a link in the description. From there, there's a whole bunch of instructions in the wiki, which are really useful, but basically you need to download the Grbl firmware as it is. So you can either use SSH and clone it using Git if that's your vibe, If not, you can just download the zip of the entire package itself. From there, then you'll need to have the Arduino IDE installed. Again, Google this, very straightforward. Arduino is very user friendly, so all the instructions are there. From here, the only kind of weird part, depending on your system, is that you have to add the Grbl firmware that you downloaded as a library in the Arduino system. So it's not necessarily super straightforward, especially if you're on Mac. It's a little bit weird, but basically in your settings you should be able to find a directory somewhere that is the library folder for your Arduino installation. You need to copy and paste the Grbl directory that you cloned down. Again, instructions on exactly which directory are in the Grbl install instructions. You need to copy and paste that into your Arduino, into the folder that your Arduino IDE is going to be looking at, and then you need to restart your IDE. From here, then, it's a little bit odd, but the way that you actually flash the Grbl firmware onto your microcontroller, you go and you navigate to the examples directory, which is inside your in the Arduino software. You'll find this. Most, if not all, of the Arduino libraries will have an example, which will basically drop the sketch directly into your editor. This is nearly an empty sketch. You don't do anything with this except you connect your board and you click the upload button. No point in me getting into the details. I'd probably get them wrong anyway of exactly how this works, but effectively this will piggyback off of the Arduino's uploading process and uploads all the Grbl firmware as it's supposed to run onto your Arduino. And then if that's all worked correctly, you basically open up a serial prompt into your serial monitor, and you'll see some response text that comes out of Grbl. It's like a boot initiation code, and from there you can start issuing commands to it directly through the serial monitor, which will let you test that it's actually there, installed, and responsive. And that's about it for the software installation. It's pretty straightforward.
Okay, we have a little test set up here. What I've done is I've set up the Arduino Nano. I have Grbl running on that now. I have my stepper motor wired up, my stepper driver wired up. I've got my stepper motor here. I've got a little flag on the end of it, so hopefully you can see it spinning when I make it do some stuff. The rest of this board is just messy wiring, nothing really to write home about. If you want to know how you wire up one of these DRV8825s, I'll throw a wiring diagram somewhere on the screen. You'll see it. You can have a look. It's pretty straightforward. You can Google it. Very easy to do. And then over here, this little guy is my switched power supply board. So the main thing that you need for this is to power a motor like so. You need more juice than you can drive out of any pins on an Arduino. You need a little bit of higher voltage as well. So I've got 12 volts or 9 volts actually coming in from my power supply into my board here. This switch here will send our 9 volts down to here. That drives the main that's the main drive voltage for the motor. And then all the rest of this shares common ground with everything, but all the rest of this is all 5 volts, which it'll pull from the Arduino, and that's just for control signals and that kind of thing. So yeah, that's really the wiring side of it. It's all pretty straightforward. If you don't know much about setting this stuff up, go and have a read about it. It's pretty straightforward. Only little weird thing is the little trim pot in here, for which you need to look up your current requirements for your motor, and then you can trim that to be what you need it to be. Again, not crazy complicated. So what I've done as well is, with the help of the internet and with the help of some AI, I've basically written this program, which is largely AI generated. I have to tell you, I'm really liking the AI recently for quick and dirty prototype stuff. So basically all this does, it's pretty straightforward. It uses a serial library that exists in Rust, and this will spin up a little interactive terminal for me, so that I can, from my computer, I can send G-code commands over the USB to the Arduino Nano and run stuff. So this is what is in this is all just test code, so I might not share this as it is, but I just want to show you what you can do with it and how it works. And then what is in this, like the control loop and how we send the commands and all that sort of stuff, I will continue to use this for testing as I develop the wider actual control software that's going to have a user interface and everything. But the bones of it, I'll use this for testing for, and like the sending and receiving data, I've prototyped on this, so I can rip this out into a proper abstraction where it can be used in other places, and then that'll be kind of the core part of the software they're going to be building. So let's have a look at how it works. So it is pretty straightforward. I have it here. So it goes, you cargo run. So this is a Rust application. So I'm in my application. I have it set up as an example that I've called serial. So I go cargo run example serial. Oh, I need to plug in my USB first. Also, I should connect my power supply. I'll turn on my power supply and set the output. Yep. So I'll switch on the power switch here. So everything's powered now. So it should be ready to go. So I'll run my code. So what this does, first thing it does is it scans all my serial ports. It tells me that I have this serial port connected, which is for my Arduino. So I select 0 and hit enter. And now it's connected to it. And we're in this interactive mode. And you can see this line that's been output here, the Grbl 1.1h, use $sign for help. That is echoed straight out of the Arduino, and that is basically the kind of boot response that comes out from over the serial port from Grbl, which means Grbl has been initiated on the board and effectively it's working and should be able to receive commands now. So I can type in any commands that are standard in Grbl, so you can use the $sign command, which basically is the help command. So it's showing me a whole list of other commands that I can type in. So if I do $sign, for example, and then hit enter, this is the config state of the machine dumped out. So this is all the basic config. You don't need to worry too much about what all of these are, but basically this is all the configuration that you can set up for your machine. So it's things like the speeds and the feeds, the accelerations, the steps, what's it, millimeters, steps per millimeter, and all that sort of stuff. So what you're doing when you build an actual machine, you need to configure all that so that it works in the real world, but it has some default set there. And I'm already ready with out of the box. I've literally done nothing to this. I have no configuration whatsoever. All I've done is I've connected 2 of the pins of the Nano, which the Grbl firmware has set up to be the x-axis. I've connected them to the stepper driver and wired up the stepper driver. Everything else is purely out of the box. And I've written some code here that can interface with all that. And it works straight away. So if I do G0, that sets... Don't worry too much about that, what that does. If you don't know anything about G-code, don't worry too much about that. But basically, it's just sets are the way we're going to run stuff. Don't worry too much. Set G0, fine. And then I can just do X10. And so what this is doing, this is telling my CNC machine, in air quotes, to move to a coordinate of +10 in the x-axis, basically. To move to location x10. That's an easy way to say that. I'm making this too complicated. Move to 10 in the x coordinate. So if I hit enter, you'll see... There we go. My stepper motor spins. So if this was actually configured properly, what ideally would have happened there is that this would have moved some distance in the x direction, which we'll call 10. It could be 10 millimeters, it could be 10 inches, doesn't matter. It's just configured as 10 units. And what you heard there or saw there was, heard and saw, hopefully you can't really see the acceleration as well, but you can hear the acceleration. You hear the motor ramp. It'll go at a constant rate and it'll ramp down again, and that's all to do with the velocity and acceleration settings that are set. So if I give it a slightly larger distance, so we're already at x10, so if I give it, say, x20, it'll go the same distance again in the same direction. There we go. And then if I give it x40, so now it'll go twice the distance, so it'll run for longer. And there we go. And then ramps back down again. And then x10, so we'll go 30 in the reverse direction, so it's even longer again. And you'll notice it spun in the opposite direction there. And there we go. So that's kind of it. That. This is basically working. So I know I've got Grbl running on the Nano. I've validated that it is working and is controlling this motor. I've got some software here on my laptop that I have also validated can send and receive data from Grbl and can effectively control the CNC machine. Obviously, this is all manual right now. The next steps that I have to do is I have to do some work to rip apart this AI generated sample garbage, pull out the relevant parts of it that I need for my actual software that I'm building, and then I can put all that together into real software. I'm gonna keep this terminal app lying around. I'm gonna refactor it with my abstractions that I make, but I think it's gonna be super useful to just be able to plug in to debug stuff and test stuff out really quickly. So yeah, that's everything for now. As I said, I might share this code as is, or I might not. Might wait till I've got a little bit nicer polish on it before I share it, so that it's just a little bit easier for other people to use. But yeah, I think that's everything for now. I'm kind of surprised that this all just went really smoothly and really fast. I was kind of dragging my heels with setting all this up because I was sort of dreading it a little bit. I shouldn't have. I don't know why. But yeah, this all works really well. So next steps, write some more code. Basically, that's it. I'm going to leave it here for this video. Try and keep this a little bit shorter than some of my recent videos, which have been really long. Hope you guys enjoyed it. Hope you guys got something from it. And yeah, as always, thanks for watching. I'll see you guys in the next one.